We're going to look at the lengths of some segments in these circles. So we've got three types of segments that we need to know the relationship with. The first type is if it's completely within the circle. So we've got intersecting chords, or technically they could be secants, but if we know the measurements inside the circle, this one's probably the easiest one to remember. They cross, so if you think about the cross as multiplying, it's A times B is equal to C times D. A times B is equal to C times D. I think it's easy to remember that it's multiplying and not adding, because when you look at the picture, it's clear that segment AB is not the same length as segment CD. It's clearly CD is longer than AB, so it doesn't make sense that if we add A and B, it will be equal to adding C and D, because they're not the same length. But there is a proportion here going on, so that's why we're multiplying. Now, type 2, here's the relationship. A times A plus B is equal to C times C plus D. Some of these, I'm going to be honest, you're just going to have to memorize it. Okay? There's not really, I guess, a logical way to think through it. It is what it is. You got to know it. This is when you have intersecting secants and part of your segments are outside of the circle. The third type there has an intersecting secant and a tangent. Okay, A is the tangent, BC is the secant, and the relationship here is A squared is equal to B times B plus C. So part of it is similar to type 2, the B times the B plus C. The other part is completely different from the others. I think to kind of remember this one, it looks like we've almost got a little triangle going on here. So if you think about it that way, kind of Pythagorean theorem-ish with the A squared in there, and then the B times B plus C is like the type 2. Again, that's the best I can come up with helping you to remember. You may just have to memorize it. All right, let's look at some examples here. Number 1, solve for x. This is type 1. Everything's within the circle, so we multiply 14 times 15 is equal to 10 times x. Doesn't matter which side of the equation you have it on, just so that the pieces that are on the same line go together. So 14 and 15 are on the same line, 10 and x are on the same line there. Okay, and then we solve it. So 14 times 15 is 210. So then we divide by 10. So 21 is our missing segment there. 21 is our x. We can also do this with some variable expressions. Okay, on number 2, it wants us to find, let's look at what it wants us to find, BD. So we've got to find this whole segment length. We're not just solving for x. We've got to take it all the way. We know part of it's 4. The other part of it has a variable expression there. So 4 times 5x minus 1. Make sure you put parentheses there. The other segment, both pieces are 6. So is equal to 6 times 6. We need to distribute that 4. So we get 20x minus 4 is equal to 6 times 6 is 36. Add the 4 to both sides. 20x is equal to 40. Divide by 20. So x is equal to 2, but that's not what they asked us for. They said find BD. So we got to plug that back in. 5 times 2 minus 1 is 9. So 9 is that missing piece of our segment. So 9 plus 4 is 13. That's what they were wanting, the whole entire piece there. Three and 4 are similar to that. I'll leave those for practice problems. Let's look at type 2, number 5. Okay, number 5 is type 2. So when it's outside the circle, when we've got two parts that are outside the circle, okay, let me color code actually. Do this segment in blue. Okay, so it's the little piece times the whole thing. So 8 times 8 plus 9, 8 plus 19, yes, okay, is equal to the other part. It's the little piece times the whole thing. So the whole thing here is 9 plus x. So if we solve this one on the left side, 8 plus 19 is 27. 8 times 27 is 216. And then on the right side, we need to distribute the 9. 81 plus 9x. So then we subtract the 81. We get 135 equal to 9x. Divide by 9. We get x equals 15. They were asking us to solve for x, so we are finished. Okay, number 6 is just like that one, so I'll leave that one. Let's look at number 8. Let's look at number 8. Number 8 says find YZ. Okay, find YZ. So I'm going to go ahead and highlight what eventually I'm trying to find. I'm trying to find that segment length. Right now it has a variable expression, so I know I'm going to have to go back and plug in. So little piece times the whole piece. So 15 times 15 plus x minus 1 is equal to little piece 12 times whole piece 12 plus x plus 8. So let's work that out. Let's see here. Yeah, let's go ahead and simplify what's inside of our parentheses here. 15 plus x minus 1 is x plus 14. And on the right side, 12 plus x plus 8 is x plus 20. Just adding like terms there. Then we can distribute 15x plus, let's see here, 15 times 14, don't want to mess it up, 210. On the right side, distribute the 12, 12x plus 240. This time we have variables on both sides, so let's move it so that we just have it on one side. Subtract the 12x first. So we have 3x plus 210 is equal to 240. Subtract the 210. 3x is equal to 30, so then x is 10. They didn't want x, they wanted yz. So yz is x minus 1, so x was 10, 10 minus 1 is 9. 9 was the final answer they were looking for. All right, so let's look at the last case here, number 9. Number 9. One segment is a secant. It goes through the circle in 2 places. One segment is a tangent. That 24 only touches the circle in one place. So the third case said that you square the tangent, and that is equal to, just like the previous examples, little piece times whole. So 18 times 18 plus x. 24 squared is 576. 18 squared, 18 times 18, 324 plus 18x. So we're going to subtract the 324. That gives us 252. And divide by 18. 14 is x. And that's what I wanted to solve for. So Solve for x, so we're finished. Let's look at number 12. Number 12, solve for x. Okay, the tangent here, we square that. Notice I'm going to put it in parentheses. Okay, because it was 3x, I have to square the 3 and I have to square the x. The secant, so it's little piece times the whole, 9 plus 16. So like I said, you got to square the 3 and you got to square the x. So that's 9x squared is equal to 9 times 25. 9 quarters is what, 225? And then we divide by 9. X squared is equal to 225 over 9. Does that divide evenly? Oh, it does. Yeah. Duh, that's how I got that answer. 225 divided by 9 is 25. So then we take the square root. Normally when we take the square root, what are we supposed to remember? Plus or minus, but we're talking about segment lengths here, so it doesn't really make sense to have a negative. Because if x were -5, that would mean that that segment was -15. So that's not going to make any sense. So you don't have to use the positive and the negative here. You just use the +5. Okay. Now, that's not to say that your x here couldn't be negative. Okay, it just depends on how they have the variable in the problem, so you need to check that. Don't think that you automatically did something wrong if you got a -x. It may work out in the problem, but in this case, it didn't. We just needed that positive. All right, let's see here. We need to do number 15. Let's do number 15 here because we've done this type. This is type 2. But this one's going to take on a little bit of a different solving, I guess you would say, steps in that we need to solve. All right, so this is the little piece times the whole, so 5.5 times 5.5 plus 22.5 is equal to the other one. The little piece was x. The whole would be x plus 15. So let's work out that left side there. 5.5 plus 22.5 is what, 28. 28 times 5.5 is 154. So we got 154 on the left side. On the right side, we distribute that x. X times x is x squared. X times 15 is 15x. What kind of equation do we have? What do we call that? When you got x squared in the equation? Quadratic. Okay. Quadratic equation. What's usually required in solving a quadratic equation? Factoring. We can't just solve for x because we've got two x's. We've got x squared and we have x. So we can't just solve for x here. We're going to have to factor. So if we factor, that means everything has to be on one side. It has to be equal to 0. So we subtract that 154 over. Okay, now we got to find some factors of 154. 9 doesn't work. 154 and 9? No. How about 8? Nope. 7?
Yeah, 7.
Okay, 7 and 22 work. Okay, 7 and 22. X plus 22 and x minus 7, because 22 minus 7 is 15. So then once we factor, we set our factors equal to 0 and we solve. So we get negative 22. Will negative 22 work? No, because x is a segment length on our diagram here. So a negative segment length is not going to work. So only the positive 7 is going to work. And then one is solve for x, so x is 7. Okay. Now, I'm going to start you on number 16. I'm not going to finish it all the way because I just want to point something out. On number 16, this is the tangent one, so it's the that tangent segment gets squared. So x plus 5 gets squared, and then the other side is little piece times whole. So 12 times 27. 12 plus 15 is 27. X plus 5 squared. How do we handle that? Oil. Okay, that is not x squared plus 25. It is x plus 5 times x plus 5. So that is x squared plus 10x plus 25 is equal to whatever 12 times 27 is. 324. Okay, now we're in the same boat we were just in. It's a quadratic. It's got to be equal to 0, and you got to factor. Okay, so I'll let y'all finish out number 16, and then I want you to go back and start working on the problems that we did not do as examples.